Welcome, this is A. Manju going to deliver lecture on topic file allocation methods. Allocation methods. Many files are stored on the same disk. The main problem is how to allocate space to these files so that disk space is utilized effectively and files can be accessed quickly. Three major methods of allocating disk space are widely used. They are contiguous allocation, linked allocation, and indexed allocation. Contiguous allocation. Contiguous allocation requires that each file occupy a set of contiguous blocks on the disk. Contiguous allocation of a file is defined by the disk address and length of the first block. The directory entry for each file indicates the address of the starting block and the length of the area allocated for this file. Accessing a file that has been allocated contiguously is easy. In this diagram, contiguous file allocation was displayed. See the directory structure. The file count was started from 0th block and continuous 2 blocks, that is 0th and first block were used for its allocation. Next, for the file tr, it has started from 14th block and continuous 3 blocks, that is 14th, 15th and 16th block were used for its allocation. Similarly, all other files were allocated contiguously. Both sequential and direct access can be supported by contiguous allocation. Disadvantages of contiguous file allocation. However, contiguous file allocation has some problems. One difficulty is finding space for a new file. In dynamic storage allocation, identifying the file size from a list of free holes is another disadvantage. As files are allocated and deleted, the free disk space is broken into little pieces. External fragmentation problem exists whenever free space is broken into chunks. It becomes a problem when the largest contiguous chunk is inefficient for a request. Depending on the total amount of disk storage and the average file size, external fragmentation may be a major or minor problem. One solution for preventing loss of significant amount of disk space to external fragmentation is to copy an entire file system into another disk. The original disk is then freed completely, creating one large continuous free space. This compacts all free space into one continuous space, solving the fragmentation problem. Another problem with the contiguous allocation is determining how much space is needed for a file. If we allocate too little space to a file, we may find that the file cannot be extended. To minimize these drawbacks, some operating systems use a modified contiguous allocation scheme. Here, a contiguous chunk of space is allocated initially. Then, if that amount proves not to be large enough, another chunk of continuous space known as an extent is added. A file can contain more than one extent. Linked allocation. With linked allocation, each file is a linked list of disk blocks. The disk blocks may be scattered anywhere on the disk. The directory contains a pointer to the first and last block of the file. Each block contains a pointer to the next block. To create a new file, we simply create a new entry in the directory. This pointer is initialized to null. A write to a file causes the free space management system to find a free block, and then this new block is returned to and is linked to the end of the file. In this diagram, linked file allocation was illustrated. The directory structure has the file name, start block and end block entry. The file Jeep was allocated first in the 9th block and then to 13th block, 16th block, 1st block, 10th block and ended in 25th block. Each blocks were linked with the pointer. Disadvantages of linked allocation. The major problem is that it can be used efficiently only for sequential access files. Another problem is the space required for the pointer. The usual solution to this problem is to collect blocks into multiples called clusters and to allocate clusters rather than blocks. Cluster can be used to improve the disk access time for many other algorithms. Another problem of linked allocation is reliability. What would happen if a pointer were lost or damaged? One partial solution is to use doubly linked list and another is to store the file name and relative block number in each block. Indexed allocation. Linked allocation solves the external fragmentation and size declaration problem of contiguous allocation. However, in the absence of a fetch, linked allocation cannot support efficient direct access since the pointers of the blocks are scattered with the blocks themselves all over the disk and must be retrieved in order. Indexed allocation solves this problem by bringing all the pointers together into one location, that is the index block. Each file has its own index blocks of pointers to its data block's address. The directory contains the address of the index block. When the file is created, all pointers in the index blocks are set to null. When the ith block is first returned, a block is obtained from the free space manager and its address is put in the ith index block entry. In the given directory structure file, G's block informations are available in index block 19. To store or allocate file G blocks 9, 16, 1, 10, 25 blocks were used and so all these blocks were indexed in block 19. Advantages of indexed allocation. Indexed allocation supports direct access without suffering from external fragmentation because any free block on the disk can satisfy a request for more space. However, indexed allocation suffer from wasted space. If the pointer overhead of the index block is generally greater than the pointer overhead of linked allocation, the problem rises with the question of how large the index block should be. Every file must have an index block. If the index block is too small, it will not be able to hold enough pointers for a large file and the mechanism of linked scheme, multi-level index, combined scheme are available to deal with the issue. Thank you.